Welcome to all of you in today's lecture number 27 and in this series of compression member design. Today we are going to discuss what are the various conditions or what are the various IS456 guidelines or design parameters which we have to take into account while designing a RCC type of column, that is RCC short column having axial load as well as uni-axial bending. So here we have to follow SP16, that is Special Publication 16, which we can say the simplified part of or simplified extension of IS456. So how to go through various guidelines, how to use the provisions and various charts given in SP16. So today we are going to discuss in detail about all this. Now, step by step, let us try to understand that what is in the design of a column, which will be subjected to axial load along with uni-axial bending moment. And what is the meaning of uni-axial bending moment, biaxial bending moment, axial load? We have already discussed in the previous lectures in detail. So if you have any doubt, anything you want to have in more clarity, then you can watch the previous lectures also. So first of all, now we have to discuss that what is the meaning of axial load as well as uni-axial bending. So that means when a column is subjected to a vertical load or compressive load, maybe having some eccentricity. So due to that eccentricity, column will be subjected to combined type of stresses. One is due to axial load, that means direct compressive stresses, and other will be some movement will also act. So that bending moment or movement will be due to the eccentricity of the load from the centroidal axis. Or otherwise, in the problem, in the design problem, we may have the information that load may be acting at a centroid, but along with some external movement is acting due to any reasons based on the structural design or structure and member location. So the design strength of an eccentrically loaded short column depends upon the extension of the eccentricity of loading. So what is the eccentricity and how much extent of eccentricity is there, whether it is under the minimum eccentricity limit recommended by IS 456 or it is beyond that. So that we have to take into consideration. Now in case of any column which is subject to the eccentric load about one of the axis, then we will term it as a uni-axial eccentricity, and the design of the section or that column will be based on the following parameters. So first of all, we have to take into consideration what is the axial load, that is factored ultimate load which is acting on the column. And the second thing we have to take into consideration, that is what is the uni-axial movement, or we will say in technical, that is the factored bending moment MU, which may be because of eccentricity or may be directly applied, not because of eccentricity. So when we refer clause number 39.5 of IS 456, then one note is mentioned very clearly in the code. So let us first of all discuss what is that note. So that note clearly indicates the design of a member which is subjected to combined axial load and the uni-axial bending will be involving lengthy calculation during the analysis. So to avoid that lengthy calculations due to trial and error method, we can easily use the interactive curves or interactive diagrams which are available in the course, that is SP16, and they have been prepared and published by Bureau of Indian Standard, and that comes in the booklet, that in the form of booklet, that is SP16 design aids for reinforced concrete to IS 456. So now the design of such type of compression member can be done as per the instructions or recommendations or the curves or charts available in SP16. And today we have to discuss how to use those charts and what are the various provisions or guidelines which we have to adopt in designing a column which is actually loaded along with uni-axial bending. Now going through the guidelines, let us decide what are the various steps which we can follow. So following steps in general may be followed in designing column which is subjected to combined axial load and uni-axial bending. So let us discuss one by one. Now step number one, here we again this step will be giving the information, that is we have to select the selection of the material and their grades again as per IS 456 recommendation, which may be based on exposure conditions. In step number two, based on the data available, we have to first of all calculate what is the factored load, that means ultimate factored load PU, and factored bending moment. So both we have to work out, we need to do the calculation. And then in step number three, what we can do, we can select a trial section for column, keeping into consideration the minimum clear cover. So here, minimum clear cover we have to first of all assume, or if it is given in the problem, then no issue. Accordingly, a suitable value of width of the section as well as depth of the section, or we can say the cross-section dimension, need to be decided. And along with, we can assume diameter of the bars which we are going to use as main reinforcement or longitudinal steel. Now then in step number 4, we have to apply the check for minimum eccentricity. Again, we have to follow the guidelines mentioned in clause number 25.3 of IS 456, as we have used and taken these guidelines into consideration in the earlier lectures, whether it may be a square column or a rectangular column or a circular column, we can say under axial load. Now, the same type of guidelines, some of the guidelines are exactly same we can use in this type of column, that axial load along with the uni-axial bending. So this was the condition which we have to take into consideration as per clause 25.3, that what is the minimum eccentricity. So based on the dimensions of the column as well as the length of the column, unsupported length of the column, we can work out a minimum, and it should be either greater than or minimum eccentricity we have to take into consideration is 20 millimeter. So where L is the unsupported length of the column and D is the lateral dimension of the column in the direction under consideration. Now, as we have discussed in step number 4, that first of all we have to ascertain what is the minimum eccentricity, and then we have to calculate the actual eccentricity which may be occurring due to the load and the moment. So actual eccentricity we can easily calculate by dividing the ultimate moment, that is coming on the section, and the axial load which is coming on the section. So accordingly, we can easily work out what is the actual eccentricity. MU and PU we have already obtained in step number 2, so we can take those values. And here we have to apply this check, that whether the actual eccentricity is greater than minimum eccentricity. So that is the only check which we have to apply. And now in step number 5, here first of all we have to calculate what is the effective cover, that is D dash, and overall depth of the section or lateral dimension. Then we have to find out this ratio D dash by D, because based on this ratio and other parameter, we will be able to get the information, and we can use the charts available in SP16. Now, after this step number 1, we have to calculate PU, that is given by this formula, ultimate factor load divided by FCK, B and D, where B is the width. the section, and D is the depth of the section. And similarly, by using this formula, we have to work out what is mu, and that means small pu and small mu. These are the two parameters which we have to take into consideration, and the third parameter is d dash by d. So based on the information available, we can go through the SP16 to get other information which is required later on. Now in step number 6, depending on the values which we have already achieved or calculated in step number 5, 4 and 5, PU, MU, D dash by D, and grade of steel. So based on all these four type of parameters, four type of data, we can select the corresponding chart which is relevant for us from SP16. Now, what are the various charts available in SP16? So when you refer SP16 and charts for compression and bending, so there are various charts, and some of the charts are relevant to axial loading, and we have to refer the charts which give you information and which are relevant for the axial compression as well as bending. Now let us discuss what are these charts. The design charts, or we can say non-dimensional interaction curves. So these charts are basically various types of curves, and we have to select the relevant curve from SP16, which can be used for the calculation of required area of steel. So here we are going to use the charts for calculation of required area of steel in different type of standard type of section. Here we have to arrange the reinforcement in a symmetric way. So SP16 is having number of charts, and all charts are based on these parameters, grade of steel as well as uniformly arranged or symmetrically arranged reinforcement. So first of all, there are a rectangular section which you want to design. So for rectangular section with the reinforcement, distributed uniformly equally on two sides. So we can refer chart number 27 to chart number 38. And for a rectangular section with the reinforcement distributed equally on four sides. So chart number 27 to 38 are applicable when reinforcement is distributed equally on two sides. But chart number 39 to 50 can be used when we have to design a rectangular section with longitudinal reinforcement which is distributed equally on all the four sides. Now, when we have to design circular type of section, then we can refer charts 51 to 62, and these charts are applicable for circular section with at least 6 number of bars of equal diameter and uniformly spaced circumferentially. Now let us explore what are the various charts which are relevant for us, that means for a design of axially loaded column with having uni-axial bending moment. So first of all, as we have discussed, there are rectangular section which we are going to design, and if the section is rectangular and reinforcement distributed equally on two sides, so let us understand it more effectively. When you refer any chart, so this will be the chart number, and now you can see this is a sectional diagram. It is a rectangular type of section having depth d and width b. Now here reinforcement is equally distributed along the two sides. So there may be number of bars, maybe 3, 4, 6 like that, but they should be, that means 50% steel is on this side and 50% steel you have to arrange on this side. So it is a very much a symmetrical type of section, and a reinforcement is distributed uniformly and symmetrically. And this dotted line will be indicating the axis of bending. Now this d dash which we have calculated, which is the effective uh, effective cover to the reinforcement. Now when you have to select the chart, suppose we have to select the chart 27, then this chart number 27 is valid for a rectangular section having uniformly distributed steel on the both sides, and for steel having strength that is 250, that means mild steel. So grade of steel is Fe250, and it is only applicable when D dash by D ratio is 0.05. So the various charts which are available for rectangular section, as we have discussed, they are chart number 27 to chart number. Now let us discuss clearly and more effectively so that we can understand what are the applications of this chart. So I have discussed that how to select the chart. That chart will be selected based on these parameters, and charts which are available, that is chart number 27 to 38. So they will be giving us the required information when and they are following these guidelines, that reinforcement is provided along two sides parallel to the axis of bending. No inner rows of steels are there, so we are not providing any inner bars, only side bars are provided. And the area of steel is distributed equally in both rows, row number 1 and row number 2. And the chart will be chosen or selected based on the value of Fy and D dash by D ratio. And chart number 27 to 30. So these charts are relevant for the information or the data when grade of steel is Fe250. And chart number 31 to 38, they are applicable for higher grade of steel. It may be Fe4, 450 or 415 or Fe500 accordingly. Now, the section, if a section is a rectangular type of section with the reinforcement distributed equally on all the four sides, so then what are the various charts which are applicable? So chart number 39 to 50, they will be applicable in case of these type of sections. Now you can see I have selected chart number 39. So chart number 39 will be selected when the section is a rectangular section and reinforcement distributed equally on all the four sides. So you can see here reinforcement is distributed on the all the four sides and it is symmetrically distributed, and grade of steel is 250 and D dash by D ratio is 0.05. So you have to keep in mind that if you change the D dash by D ratio, then you have to follow the other chart. Again, here these are applicable when reinforcement provided equally on the four sides. Two outer rows, so this row and this row, they have the area that is 0.3 of ASC. That means 50% of the steel is on the these sides. And four number of inner rows. If we are providing four number of inner rows, then 0.1 into ASC will be distributed here. So chart will be chosen again based on Fy and D dash by D ratio. And chart number 29 to 40 are applicable when grade of steel is Fe250. And similarly chart number 43 to 50, they are applicable for higher grade of steel, as already discussed, that it may be Fe450 and Fe500. So accordingly, charts are available and we can select the relevant charts for design purpose. Now, when we have to design a circular type of section with the reinforcement again equally distributed or uniformly distributed along the circumference of the circular section, then the charts which are applicable in case of circular section, they are charts number 51 to 62. And let us understand that how this chart is applicable. So chart 51 will be selected when grade of steel is Fe250 and the D dash by D ratio is 0.05. And you can see here the cross section. This is a circular type of cross section of the column, and reinforcement is equally distributed. Now various provisions we have to keep in mind, that these charts are applicable only when reinforcement provided having at least 6 number of bars. And the charts again will be chosen based on Fy and D dash by D ratio. And the chart 51 to 54, they are applicable for Fe250 type of steel. And the chart 55 to 62, they are applicable for higher grade. Now, very important part of the today's lecture is that how to use these charts which are available in SP16 So first of all, we have to calculate D dash by D ratio, then PU, then MU as we have discussed earlier. And we will be discussing here three type of example. Now first example, suppose we have to design a column which is having grade of steel Fe415 and it is a rectangular type of section. Now suppose we are calculated that D dash by D ratio comes out to be 0.1 and the PU is coming out to be 0.35 and MU is coming to be 0.15. Now based on this information, that means D dash by D ratio and Fe415, we can select this chart number 32 is applicable. So what is this chart 32? So any chart in SP16 will be shown like this. So that means you can see at the top right corner, grade of steel is mentioned and D dash by D ratio it is mentioned. So here RD dash by D ratio is 0.1. Yes, here it is also 0.1. And grade of steel is Fe415. Again, it is Fe415. And we are going to design a rectangular section. It's okay. And reinforcement is equally distributed. And based on various curves, you can see here number of curves are there. And along x direction or along x-axis, you can see this is given that mu by fck bd square. So that is small mu. So you can say here along this side there is small mu. And along y direction you will find the formula and that formula will give you the value pu. So that means these charts are drawn between small pu and small mu, which are already mentioned here. And this chart is applicable only when grade of steel is Fe415, D dash by D ratio is 0.1 rectangular section as we have discussed already. Now, how to select the value or what value this code or this chart will be giving us. Now you see here, as you can easily understand from these two lines, these red color lines. So since PU value is 0.35 for us, and you can see along vertical direction or along y-axis, this chart is having denomination that is 0.2, 0.4. So somewhere in between, here you will get the value that is 0.35. And another parameter or another information that is MU. Now MU here we have 0.15. And you can see here along x-axis the denomination given is 0.1, 0.2, 0.3, 0.4 like that. So here somewhere 0.15 will exist. Now what we have to do, we have to draw two perpendicular lines. One is parallel to y-axis which is passing through 0.15 and another perpendicular line from 0.35 and which is parallel to x-axis. Now somewhere they will be intersecting and this yellow color point is indicating that they are intersecting somewhere here. Now if they are intersecting and that intersection point where they are meeting is lying on a curve, then that point will be important for us because that point will give us information. Now how it will give us information, you can see here. Now these two lines, that mean these two, one vertical and one horizontal line passing through the required mu and pu value, they are intersecting here and that point is lying on this curve. So this curve, and from this curve you can see this curve is having the value small p by fck. So you can easily see here p by fck, small p by fck value is 0.1. So this curve is relevant when small p by fck is equal to 0.1. So based on this interactive curve, we are getting the value of p by fck is 0.1. Now what is p? P is the percentage of steel. Small p, it is the percentage of steel. So what we are getting, we can get from this value, what is the percentage of steel required. So that will be 0.1 into FCK and grade of concrete. Based on grade of concrete, you can easily work out that this much percentage of steel is required. So based on this percentage of steel value, we can easily work out that how much is the area of steel required. So that will be P by divided by 100, that is 3%. into gross area of the section. So this is the way how we can get the information, that means the data or value of P by FCK, and based on that value we can easily work out that what is the area of steel required in this type of a section which is having all these type of parameters. Now let us consider another type of example. Suppose again grade of steel is 415 and the section is a rectangular section. But now you can see here D dash by D ratio is 0.1. Okay. And small PU ratio is coming 0.2 and small MU ratio is 0.3. So how to get the value or how to select which curve is applicable here? So first of all, based on this PU value 0.2, we have drawn a line and which is parallel to x-axis, and based on a small mu value 0.3, we have drawn a vertical. So they are meeting at this point, and this black color dot is indicating their meeting point. So that means intersection point. Now you can see here very clearly this point nowhere touch any curve. So it is in between these two curves. So how to get the value? So how to get the P by FCK value when the point is not lying on the curve? So you can see here clearly that this point is lying between two interacting curves. So one curve is belonging to P by FCK value 0.2 and the other curve is belonging to value P by FCK 0.18. So it is lying between 0.2 and 0.18. So how to calculate? It's very easy. We can do the interpolation between the surrounding two curves, or in simple way you can take the average value of the two curves. So that means average value means 0.2 plus 0.18 by 2 approximately we can take FCK value. So based on that we can work out what is P, percentage of steel required, and then using the again same formula we can work out area of steel which is required in this type of case. Now if this third type of case emerges, here you can see that D dash by D ratio is 0.12 and PU is 0.2 and MU is 0.3. So when you refer the charts in the SP16, you will find that no chart is belonging to D dash by D ratio 0.12 because chart will be available for D dash by D ratio 0.1 or 0.15. So based on this, so intermediate value is not available. And how to get the value? That is the point of concern. So how we have to do this calculation? So for this, we have to interpolate the value taken from two charts. So now we will be selecting two charts. So maybe one chart is like this. So this is for an example we are taking. Suppose this chart number it is belonging to D dash by D ratio 0.1 and other chart maybe chart number 33 belong to 0.15. So that means we have to select two charts and based on the previous methodology, we will be getting two values. So let us consider these two values we are getting. Suppose from first chart we are getting P by FCK value x1 and from chart number 33 we are getting P by FCK value x2. So then what we have to do? We have to arrange these values in a table and for the interpolation. So how of first chart is for D dash by D, that is 0.1 and FCK PU FCK value is x1 as we have discussed, and for 0.15 it is x2. So we are interested in this value, that means what is the value belonging to 0.12. So it is very simple, we can do the interpolation and we can easily work out the value of x, that is value of P by FCK which is belonging to this value of D dash by D. Accordingly, we will be able to calculate what is the percentage of steel required and what will be the area of steel required. So this was the illustration how to use SP16 charts in the design of columns which are actually loaded and uni-axial bending, various type of column, rectangular column of different types as well as circular column. So all these information we have discussed so far. And in the next lecture, we are going to take one example based on these type of studies. We can say these type of design parameters, and you will be able to understand more clearly that how to practically use these charts when we have to design a column. So in the lecture number 28, we will be going to design a column.